So everybody, welcome to World Hydrography Day here at KAUST. My name is Frank Mallon and I'm here with my colleague Brian Hessian. I suppose I should better start off with asking two questions. What is hydrography and what is World Hydrography Day? Hydrography is traditionally the detailed mapping of the seabed to produce safe navigational charts. This was once done using simple lead weights and very long ropes to collect depth readings. But with modern technology, this has evolved to encompass many different research fields, from acoustic surveying to physical oceanography, and even development of autonomous marine vehicles, and also mapping of the seabed and sea surface from space. What is World Hydrography Day? Well, in 2005, the International Hydrographic Organization and the United Nations decided to celebrate World Hydrography Day to ensure the world's oceans, seas and rivers are properly surveyed and charted using these modern techniques. This year's theme is enabling autonomous technologies. Now, hydrography is critical to the work being conducted here at KAUST. Data recovered is being fed into climate models, world fishery studies, subsea geology, oil and gas research, and even medical research projects. With two dedicated survey vessels with deep sea capabilities, KAUST researchers can reach any section of the Red Sea shortly after leaving our dedicated harbour facilities. With these vessels, we can now make our own maps, which is a big improvement on using charts that were made from survey data collected last century on wooden sailing ships. Hydrography is also critical to the work being conducted with the Saudi Aviation Investigation Bureau. The agreement between KAUST and the AIB was signed in 2016, and this allows for the use of our advanced facilities and expertise in the event of an aircraft incident. The goal of today's talk and future events we're planning is to showcase KAUST's capabilities to the global hydrographic community and to kickstart discussion and future research in autonomous marine technologies. Now I'm going to be handing over to Brian, who's going to give a brief introduction to our division.
Yep, thank you, Frank. So as Frank mentioned earlier, we both work for the Coastal and Marine Resources Core Lab, which is also known as CMOR here at KAUST. Now, CMOR's role is basically to support all forms of marine research that go on at the university. And that can include anything from supplying diving equipment to the scientific diving community, and also to providing small boats to carry out research in the reefs in and around KAUST. And we also operate a larger research vessel called the RV Thule, and that is kitted out with oceanographic equipment of the type like C2D rosettes or plankton nets that scientists from KAUST can operate from the vessel anywhere in the Red Sea. And onshore, we also run a research aquarium facility, and that has associated lab spaces with that. So of course that all means that over the years we've been engaged in a huge number of projects, and a significant proportion of those have included hydrographic operations. So what we're going to do today is obviously take a look back over some of those projects that we've done over the last few years, and first off we're going to look at a project where we worked with Caladan Oceanic back in February this year. And when Caladan Oceanic came with their manned submersible, the limiting factor, here to KAUST to visit some of the deepest points of the Red Sea. Caladan are probably best known for setting a world record for being the first team to visit the deepest point of all the 5 world's oceans in a manned submersible. Now, they completed that 5 Deeps expedition in 2019, and later that year they were at a meeting of international research vessel operators, and there the Core Labs invited them to come visit us here at KAUST to give KAUST researchers a very rare opportunity to look at the deep brine pools and extinct underwater volcanoes that we have here in the Red Sea. Now, hydrography, of course, played a very important role in Caladan's world record attempt, because they needed trustworthy hydrographic data to verify that they were diving in the deepest areas of each ocean. Now, to do that, they fitted their research vessel called the Pressure Drop with a full ocean depth multi-beam sonar system. And that was the same system that they used here in the Red Sea when they surveyed in and around the brine pools to help them decide where to deploy their autonomous deep sea landers that they use to collect environmental data, and also it helps track the position of the manned submersible, the limiting factor. It was also used to plot the route that the limiting factor used to explore the brine pools. So nothing more to do, but let's take a look at that exciting cooperation with Caladan and KAUST.
As we executed the expedition this year, we noticed we were going from the Mediterranean to the Indian Ocean. The idea was here at the north part of the Red Sea to board the ship and then go down the spine of the Red Sea and do some very unique diving that very few people get to do, especially with a deep diving submersible. Overseeing our science mission on this year's expedition is Dr. Alan Jameson of Newcastle University.
So there's two major scientific components to this. One is based on the landers that we're using, and the other one is based on the sub. We have 3 landers. To prep them, we normally bait a high-definition video camera that lies close to the sea floor, and that collects data of live animals in their natural habitat. We have small invertebrate traps which collect very small animals we use for genetic studies. It also collects 10 litres of bottom water samples, and we can use that for a variety of things. So the landers are launched over the starboard side of the vessel, so when we put it in the water, we let it go, and it just free falls to the seafloor, crash lands. Everything is pre-programmed, everything works completely autonomously on its own. Eventually we'll pick up the lander on sea surface, bring it back on board, and then we start downloading the video to have a look at what we've got and to assess the success of that dive and then how to play the next day. The secondary component of the science involves the submersible.
In the northern part of the Red Sea was our first target, the Kerbit Deep. And that was really exciting because it would be our first exposure to the very unique feature of the Red Sea, which are these brine lakes at the bottom of the Red Sea.
Here we are. This is the Red Sea dive to the Kerbit Deep. I'm here with Dr. Alan Jameson. This is We Can Discover Your Pilot. We think we're going to go down to about 1,530 meters to the brine pool. Yeah, we're in it. We're in it. See how, look how, that was it. That was the brine pool.
I think we just bounced off of it.
We just bounced off of it. And look at that. Do you see that?
Yeah.
How it looked like a wave coming in?
Yep. What a brine pool is an area of extremely salty water. So it's so salty it doesn't mix with the seawater. So it actually looks like an underwater lake. You see it shimmering there.
Yeah. That's it. We just dipped in the brine pool. Who's done that?
As a scientist, the opportunity to join an organisation or an outfit like this with the submarine and the landers and the multi-beam and the ship and be able to take it around the world, and it's just unbelievable. It's not an opportunity that comes very often, and hopefully we are definitely going to make the most of it.
Maybe the most challenging thing about deep water diving, believe it or not, is actually getting the permits to dive in the exclusive economic zone of these countries. And without the cooperation of King Abdullah University of Science and Technology, I don't think it would have happened. I was fortunate enough to meet Justin Mayer in the United States, who's one of the executive directors of the university. We were able to coordinate offline and get the cooperation of the Saudi authorities to issue us a permit to dive in the Red Sea. As part of the whole process of cooperating with KAUST, I was provided the opportunity to present to well over 100 science members, faculty, and members of the Saudi military about the 5 deeps, but also what we're doing here in the Red Sea. I was very impressed by the King Abdullah University, the level of resources they have in terms of one of the world's fastest supercomputers, exotic and capable electron microscopes and magnetic imaging systems. It was just extraordinary, really eye-opening just to see how much capability that they had. So we're near the Suakin Deep in the southern part of the Red Sea, and today the team is dropping myself and my scientific observer into the crater of a volcano underwater. So that's kind of a Thursday for us here. So we're going to go down and take a look at the geology and some of the unique characteristics of this area. Probably about a 5-hour dive.
This is the dive to the Suakin Deep, the first one. We're headed into a dormant volcano. There it is. Yeah. Those are rocks. I think we're on the top now.
Yeah.
1900 meters. It looks very smooth.
And so our objective is to do at least 2 dives there to collect more science information, but also to take down, hopefully, a Saudi national to be the first person, along with myself, to the bottom of the Red Sea.
It's getting lighter. And there it is. Congratulations. We're the first people to the bottom of the Red Sea.
Amazing.
Now when you see it on the map, you can go, I've actually been to the bottom of that. It's pretty fun.
We made the first manned submersible dive to the bottom of the Suakin Trough, which is the deepest point in the Red Sea.
It was such an honor to work with KAUST and the Saudi Arabian government to actually do so much science and so much diving in the Red Sea.
It's just great to bring these opportunities to other people and explore places where no human being has actually personally laid eyes on them. It's a great feeling.
Thank you, Brian. That was an awesome video. Really great to see Mohammed there. You know, Mohammed, our marine electrical engineer, he got a chance to get inside that submarine, didn't he?
Yeah, we're all very jealous of Mohammed there. We some of us got to go on the vessel for a period, but Mohammed was the guy who got to get inside and take a trip to the deepest point of the Red Sea at the Suakin Deep, and got to set a world record as well.
Yep. That's awesome. Yeah, well, that brings me on to the KAUST and Fugro partnership. April 2018, KAUST and Fugro signed a memorandum of understanding here at KAUST to set up the Fugro Centre of Excellence for Marine Technology. The signing took place on the campus and marks the beginning of a mutually beneficial partnership between the two organisations. Now, Fugro is one of the world's leading offshore survey companies, and this partnership with KAUST has huge potential. To date, large tracts of the Red Sea remain unexplored due to extreme depths, temperature and salinities. Extreme environments require cutting-edge technologies and highly skilled professionals, and this is one of the benefits that we're going to be able to tap into with Fugro. Also, the location of KAUST on the shore of the Red Sea it puts us in a prime position to address these challenges. Another initiative that was set up was the Fugro remotely operated ROV training program here at KAUST. The first course was delivered at the end of 2018 here at KAUST, and this is an amazing opportunity for KAUST researchers and scientists to get an industry standard ROV pilot training course, and then that permits them to use our deep water ROV vehicles here in the Red Sea. So now here is a short video with Seymour director Lloyd Smith and Professor Burton Jones giving their take on the importance of this collaboration. This was filmed on board the Fugro survey vessel Kobe Ruug on its first visit to KAUST.
The owner of the vessel, Fugro, came to KAUST looking for collaborations and looking for synergies. They want to serve the greater Saudi Arabia with this kind of technology and this kind of training. And we've opened up a Centre of Excellence in marine technology. And we're talking about all kinds of collaborations now where Fugro and KAUST can really get together and push marine research.
Well, I think this vessel brings some unique capabilities that we haven't had up to now. Having access to a vessel like this, being able to put an ROV, being able to put appropriate sensors on it, and maybe even putting some deep moored sensors out there using this vessel to place them could provide us an advantage to look at that system in a lot more detail and understand it much better.
Here in the spine of the Red Sea, you have several dips, very, very deep points in which you have very particular set of sediments. Especially this group, this Fugro group, can help us to get to those points in a very, very reliable and accurate way.
Well, these vehicles can do 2,000, 3,000 meters. And in the depths of the Red Sea in the middle, it's nearly 3,000 meters. So this is one capability that we did not have before this agreement with Fugro.
that's definitely one of my favourite memories from KAUST, Frank, is coming back in on our own vessel into KAUST and seeing the Kobe Ruegg anchored outside KAUST there, with faculty visiting it to check out all the equipment on board and all the facilities it had for collaborations with KAUST.
Yeah, that was awesome, and that vessel's almost double the size of ours. And as you said, getting the scientists on board to see a big deep ocean survey vessel was also another unique opportunity.
Yeah.
So Brian is now going to do a little chat on gliders, I believe.
Yep, that's right. Thanks, Frank. KAUST has been here on the shores of the Red Sea for just over 10 years, but even since the earliest days, it's been using autonomous technology to explore the Red Sea using sea gliders. So Seymour has supported Professor Bert Jones's Integrated Ocean Processes group with sea gliders since 2011. And since those times, we've also expanded our autonomous fleet to include a Remus 100 AUV. And we've used that for such projects as exploring shallow waters around reefs for ghost fish traps, and doing side scan surveys of fish farm outfalls to look for environmental impacts. But a key kind of milestone for us with autonomous technologies was back in November 2015, when one of the sea gliders we operate for Professor Burton Jones reached 1,000 dives, creating 1,000 sea profiles over a period of 145 days. Now, to put that into context, before 2015, there were probably only 1,500 sea profiles collected from the entire Red Sea in the previous 100 years. Or to put it another way, if our research vessel, the RV Thule, was to try and collect that many profiles, it would probably take it the best part of a year. So we're going to look now and look back at that time in November when we had that milestone of 1,000 sea glider dives.
I'm an oceanographer, so what we're focusing on is the Red Sea, and we're trying to understand how the physics and the biology of the Red Sea work together to make it a functioning ecosystem. Starting in oceanography, I mean, that started back when I was a kid. We always vacationed on the ocean. I grew up in the middle part of the U.S., away from any ocean, but we always vacationed on the ocean. So that's where my interest in the ocean began. I'd actually worked in the Arabian Sea back in the mid-90s. And ever since that time, I'd had an interest in returning to the region and working in the Red Sea, but never had that opportunity. So when I saw the opportunity here at KAUST, I thought that could be an opportunity to come and work on the Red Sea and do some of the work I'd wanted to do a long time ago. And so by being here, it's sort of fulfilling a desire I've had for about 20 years to come back and work on the Red Sea. Well, we're using gliders on the Red Sea. The gliders are basically robotic submarines, small. They're about 2 meters long. They can make measurements of some physical properties, and we measure some optical properties that inform us about the biology. We measure oxygen. We can measure some other chemicals with it. And it allows us to have a continuous presence in the ocean, looking at both the change in the ocean in space and time, and we can leave these out for months at a time. So it would be very difficult to keep a crew on a ship out for months at a time, but a glider could stay out for a long time. We have one operating up in the northern part of the Red Sea off of Duba. We have two here in the region between KAUST and Yanbu. We have a line that we've been running. We actually started it back in 2013, but we've just been running it really continuously since just this year. And so we have one glider returning on that line. Last night, as of about 6 p.m., that glider completed 1,000 dives. I think it's up to dive 1,004 or 1,005 now. It does a dive about every 4 hours. And that's quite a benchmark. Up into 2011, there had only been about 1,500 profiles of temperature and salinity in the Red Sea. These were all obtained by ships, and so, you know, the ship, you bring up to a station, you put your instruments down, obtain a profile, pull everything back on board, the ship moves again. The glider is continuously doing profiles as it's undulating through the water from the surface down to about 1,000 meters. It's grabbing a profile on each dive. So that glider alone is now up to 1,005 or 1,006 dives. The glider off Yanbu has about, off Duba has about 350 dives. So just from those two efforts alone, we're almost as many profiles in the Red Sea in a few months that they'd had in maybe 100 years of effort prior to that. So it's transformed the amount of information that we have about the Red Sea quite dramatically. One of the great things about this, and this is coming from both our gliders, we're seeing things in the Red Sea that people have not seen before. Because as I mentioned, there's only been sort of a limited number of observations in the Red Sea before. So there have been certain things that people have said, this is the way the Red Sea works. And it's because they took the data that was at hand and they interpreted it and said, okay, this is what's happening. With the gliders, we're already seeing things that are different from the way people interpreted the way the Red Sea works. We're seeing this both here in the region between KAUST and Yanbu. We're seeing it up in the north. And so processes that are happening in both these regions are a bit of a surprise to us. And they break some of the dogmas on how the Red Sea works, but that's part of the excitement, and which we thought it would happen, but we actually do see it happening. And so by being able to keep this glider out there for that kind of a period, we can actually see these processes happening and find out how persistent they are and how important they are to the system. So it's to us, it's transforming. They will transform our understanding of the Red Sea.
Great to see those gliders. I think we've spent hundreds of hours on our different ships recovering and deploying those. Isn't that right, Brad?
That's right. Yeah, many happy hours on boats pulling gliders out of the water.
Yeah, it's also great to see that picture of the Remus. I remember the last time you came back from doing a survey in Jeddah. How many shipwrecks did you recover in that one?
It was 4, and we weren't even looking for them.
Yeah, that's awesome. Not even charted as well. So I'm going to talk now about a few upcoming events that KAUST are pleased to announce. We're going to be doing a series of monthly web-based tech talks that will explore the future of autonomous technologies here at KAUST and in the Red Sea. This is going to involve exploratory talks with industry leaders like Sonardyne and KAUST faculty. And these are going to take place when we get back in September. There's also going to be a new dedicated KAUST hydrographic website that's going to showcase our past projects and also showcase some future potential projects. And finally, internally, KAUST will be launching a series of hydrographic e-learning modules, which I'm very excited about. This is going to be in conjunction with SkillTrade, an IHO accredited training facility. This is going to be a first for the kingdom, so really looking forward to that. And Brian, now you're going to be talking about the future.
Yeah, looking forward to those talks. That's some good stuff for the near future. Yeah, so what about the longer term future for hydrography at KAUST? Well, KAUST is unique in that we have a variety of research divisions here and state-of-the-art core labs filled with cutting-edge technology and, of course, skilled and well-trained personnel who know how to use it to its fullest extent. So that gives us all a very firm base with which to approach hydrography's new era of autonomous technology. Now, what form that would take, there's lots of options available to us. And that could include the potential for a smart bay network, which would involve multi-sensor platforms installed on the reefs around KAUST. It also might involve using an artificial intelligence for hydrographic data collection and processing. Another thing we're certainly interested in is the development of, specialized subsea autonomous vehicles to investigate the extreme brine environments we have in the Red Sea. And one thing that's definitely very relevant to us now is perhaps expanding our ability to carry out autonomous surveys offshore and, of course, increase our capacity for telepresence to use for teaching from our research vessel. So a lot of opportunities potentially there for us here at KAUST, I think.
Yeah, and definitely the remote survey options and the autonomous vehicles. With the post-COVID world that we're living in, I think that's going to be very key for a lot of research institutes.
Yeah, it's really brought it home these last few weeks, just the advantages that technology can bring for us.
Yeah. Well, that concludes today's talk. Thank you for listening and hope to see you again in September. Thank you.